Good afternoon, welcome to my presentation. I am Gitti Kunsnit from Graduate School of System Design, Tokyo Metropolitan University, Japan. I would like to talk to you about evaluations of strong and weak signifiers in a web interface use eye tracking heat maps and machine learning. So let's start with heat map. First, I'm going to explain about heat map in usability evaluation, which is eye tracking heat map. What is signifier? How heat map help to evaluate a good interface, and basic concept of eye tracker. The heat map is the first image technique to play an essential role in analyzing web interface. The eye tracking heat map is a data visualization which comprises different color spectra that display on the part of the web page receiving the most interest from website visitors. Most web designers use eye tracking heat map to make datasets comprehensible and applicable in usability evaluations. The eye tracking heat map color shade reflect a user interest level in different parts of page, with different level of interest represent just different colors. Generally, the color red indicates that stone receive the most attention, and green indicates the second greatest degree of attention. In contrast, colorless elements represent area on the web page which attract the least interest from users. Figure number 2 provide example of eye tracking heat map for evaluating a website interface. What is signifier? Signifier is a sign physical form such as visual representation, label, sound, printed word, or image, as distinct from its meaning. For example, garbage shows sign in circle, four-drop can, and water bottle. If you can see one bottle in info page, it is perceivable that one bottle has get important than this. The true version different in the use of signifier as interactive element, namely text and link. The strong signifier version on the right include underlined blue text used on interactive element only. In contrast, the weak signifier version on the left uses plain text instead as shown on this figure. How heat map help to evaluate a good interface? This slide shows the left image is a web interface with a weak and low signifier, while the right image is about the web interface with strong signifier. If you look at this slide, you can see eye heat map that display transparent warm and color. That area attract user attention to greater and lesser degree as indicated by eye tracking data. Basic concept of eye tracker. The eye tracker consists of high-resolution camera, light source, and image processing algorithms. The eye tracking basic concept is used to the light source to create a pattern of near-infrared light on the eyes with high-resolution camera used to record an image of the user eye movement. Lastly, specific detail in user eye and reflection pattern are obtained with an image processing algorithm. An outline of eye tracker as shown on figure number 4. The objective of this study was to propose a method to evaluate web usability using eye tracking heat map data and machine learning algorithm. This research was conducted for preliminary experiments. This is fundamental state that's focused on signifier classification. Our framework presentation as follows. First step, data acquisitions and data preparations. Second step, build classification model, evaluate model. And third step, predict the signifier type. Experiment setup. Eye tracking heat map in this study were obtained from 11 university students aged 22 to 24 years. They were first entered into a preliminary experiment in which they were divided into two groups. The first of 6 participants who visit webpage with weak signifier, and the second of 5 participants who visit a webpage with strong signifier. The true version different in the use signifier as an interactive element, namely text and link. The strong signifier version on the right include underlined blue text used on interactive element only. In contrast, the weak signifier version on the left use plain text instead, as shown in the image. Before start, we explain them to find and then click on the shopping link. Data acquisitions. The 11 participants were then requested to set the eye tracking device to record their eye behavior while they visit the e-commerce website. Eye tracking heat map were then recorded by gathering data on the most and the least attentions, capturing sections and elements of one web page during viewing web interface. Data preparations. After data collection, the data preparation will conduct into 3 steps. First, we resize on image to reduce processing time and make them suitable for processing. Second, we convert eye tracking heat map file 3 dimensions of individual image to a feature matrix. Third, we use principal component analysis or PCA to reduce high dimension vectors into a set of lower dimension vectors. Data format for machine learning. Before building the classification model, we need to transform eye tracking heat map image to the numerical value that is suitable for pattern of machine learning. In this slide, show our process. Our process fattens a 3-channel matrix and keep its data as one-dimension array. PCA compute the height gen vector and height gen value of covariance matrix from data to identify the principal components. The step of PCA transform those sets one-dimension array to PCA datasets. Each of eye tracking heat map was processed and transformed by these techniques before both modeling. Let's move to build classification model. When finished data pre-processing on heat map data from participants and strong and weak signifier as a label class were used to build machine learning model. Leave one out cross-validation was used to evaluate the performance of classifications. This slide shows comparisons results from 10 candidate classification models. I compare these 10 different machine learning methods to compare between original heat map datasets and with PCA datasets. If you look at this chart, you can see the results show that decision tree learning algorithm provide the best accuracy 90%, as shown in this slide. Conclusions. To sum up, This presentation purposes a method to evaluate web usability using eye tracking heat map data and machine learning algorithms. The dimensionality reduction techniques was used to reduce the complexity of eye tracking heat map data. It also maximally maintains of feature measure representation and appropriately evaluate the apparent signifier in the web interface. The results show that purpose classification model that combine decision tree and PCA technique achieve greater than 90% accuracy when compared with 9 other classical machine learning methods. This study finding indicated the machine learning process help in decision-making on web interface usability. Regarding future work, further research should expand into real situations, how to evaluate more signifier on web page. Thank you for your attention.